Okay, so now let's take a look at an elastic collision. This is where they bounce off of each other. And so what we can say here is that we have our 5 kilogram block moving to the right at 3 meters per second like we did before, and it's going to collide with our 1 kilogram block, which is not moving. But since they bounce off of each other, in the end our 4 kilogram block ends up moving away at 4 meters per second. So we know the initial and final velocity of the 1 kilogram block, and only the initial velocity of the 5 kilogram block. So I'm going to call that block A and that block B. So one way we can approach this is, as we did before, was looking at the opposite impulses. So we have the change in velocity, or the change in momentum of block A, and we know that's equal to the opposite of the change in momentum of block B. And so to expand those out, we know that that's the mass of A times the final velocity of A minus the initial velocity of A, right? So that's the expression for delta PA. Delta PB, the change in momentum of block B, would be the opposite of that, and it is the mass of block B times the final velocity of block B minus the initial velocity of block B. So there's my basic equation. Now I substitute in values. So I know that the mass of block A is 5 kilograms. The final velocity of block A I don't know. That's what I'm looking for, so I just leave it as V sub A, minus the initial velocity of block A, which is 3 meters per second. That's equal to the mass of block B, which is 1 kilogram, and don't forget this is negative, times the final velocity of block B, which I know now, it's 4 meters per second, minus the initial velocity, which is 0 meters per second. So I'm going to apply the distributive property and get rid of these parentheses. So I've got 5 kilograms times the velocity of A, so 5 kilograms V sub A times V sub A, minus 5 kilograms times 3 meters per second, it's negative 15 kilogram meters per second, is equal to negative 1 kilogram times 4 meters per second, negative 4 kilogram meters per second, plus 0. So now I have to combine like terms. I have kilogram meters per second here and here, and so what I'm going to do is I'm going to add, since I want to get to V sub A, I want everything else on the other side, I'm going to add the 15 kilogram meters per second to both sides. That would give me 5 kilograms times the velocity of A is equal to, so 15 plus negative 4 is 11 kilogram meters per second. And then if I divide both sides by 5 kilograms, I'll get the velocity of A by itself. That's what I'm looking for. So I get 11 kilogram meters per second divided by 5 kilograms. So the velocity of A then comes out to be 11 kilogram meters per second divided by 5 kilograms is 2.2. And notice that the kilograms will divide out, so that is meters per second. So that is how I could solve this elastic collision using the opposite impulses. Another way to look at that is, as we did before, is recognizing that since the impulses, the momentum is just being transferred from one car to the other, that the momentum of the system in the end is equal to the momentum of the system in the beginning. And to find the momentum of the system, you just add the momentum of each object up and add them together. And so, in this case, it's going to be the momentum of A plus the momentum of B, and these are initial, is going to equal the momentum of A at the end plus the momentum of B at the end. So, if I write this out, I know that initially B does not move, so it does not have any momentum in the beginning. It's just going to be the momentum of cart A, block A. That'll be the momentum of my system. So that's 5 kilograms times 3 meters per second. And then that's going to equal the momentum of both of these objects together. So I don't know the final velocity of block A, so that's just going to be 5 kilograms, that's its mass, times its velocity. But for cart B, I do know what the final velocity is. It's 4 meters per second. So that's 1 kilogram times 4 meters per second. So if I multiply these two together, I get 15 kilogram meters per second is equal to, can't do anything with that, 5 kilograms times v sub a plus 4 kilogram meters per second. So I'm trying to get v sub a by itself, so I'm going to add this term to both sides, and if I'm going to subtract it since it's positive. So I get 15 kilogram meters per second minus 4 kilogram meters per second gives me 11 kilogram meters per second, and this is equal to 5 kilograms times v sub a. So therefore, v sub a, if I divide both sides by 5 kilogram meters per second, or 5 kilograms, is 11 kilogram meters per second divided by 5 kilograms, and as before, 11 divided by 5 is 2.2 kilograms divided out meters per second. So again, we can see there's two ways to solve these elastic problems, either based on the opposite impulses or on the fact that the momentum of the system does not change. Which one you choose is up to you, but very often one is a little bit simpler to set up than the other. In this particular case, I think that using the conservation of momentum, in other words, the momentum of the system doesn't change, maybe was a little bit easier. You decide.